Okay, we are recording.
All right. Okay, so welcome everybody to this Tech Talk, another edition, and there's many more to come, which is the part I'm so excited. We have so many talks lined up until many months, and there's so many topics from like management to documentation to game design. It's pretty cool. We have some cool stuff in the pipes.
Yeah.
So welcome. So and this is a Tech Talk by the Collab Lab. And what is the Collab Lab is one of the first questions we want to answer. So Andrew, do you want to tell us what the Collab Lab is first?
Sure, although like half the people on this call could probably tell people what the Collab Lab is, because a lot of y'all have gone through it. But I'm Andrew, I'm the founder of Collab Lab. Stacy's my co-founder, and we put the Collab Lab together to help early career developers kind of get their foothold in tech. And how we do that is by putting people on teams of 4 with professional web developers as mentors. You work on a project over the course of 8 weeks. And sorry, I'm admitting people at the same time I'm giving my spiel.
Yeah,
but, yeah, you want to take it over for a minute? I think I do for now. Anyway, yeah, you work on a project for over the course of 8 weeks, and it's just about 5 hours per week, but you build a simple app over that time, but really the focus is about how to work on software teams together. So we emphasize pair programming and code reviews, submitting PRs, demoing your work, a lot of the activities that software teams do in the real world. So it's all free to participate, and we happen to be opening up our next round of applications this Sunday. So it's open for a week. We'll be taking applications, and we'll make selections for the January, what we're now calling the winter cohort. So in 2021, we're going to run a winter, spring, summer, and fall cohort. So we'll do one each quarter, probably about 5 teams each time. So yeah, how many 5 teams? I see those eyebrows, Mindy. Like 5 teams.
How many people are applying for how many positions?
Yeah, that's a good question. It's pretty competitive, actually. So last time we had around over 200 applicants for 4 teams, so 16 spots. So a little tip is just that we're really about collaboration. It's not really about, we're not teaching coding. So in your application, this is like the insider information because you're on the Tech Talk. This is a reward for being here. Really emphasize that you want to learn about how software teams work. It's really about that collaboration side. That's the thing that we're teaching. So if that's your interest and that's what you want to get better at, you should apply for the Collab Lab. So good question.
All right. Well, thank you so much,
That's enough
Andrew.
of me talking.
No, that's great. I mean, I think it's great. I mean, it's such a great program. It's worth taking the time to introduce it, and it's also there's different locations. It's happening in North America, in Europe, and also South America. That's very exciting. Yeah. Anyway, so and I guess one of the transition I want to make is like our speaker tonight. So David Lluna is actually a mentor of the of the first Europe cohort of the Collab Lab, and he's going to talk about DevOps tonight. And DevOps is a really cool topic. Cool. I guess I guess I should not hype it because it's already hyped so much, but it's a very interesting topic. At least it's dear to my heart. Sometimes I do DevOps all day at work. So anyway, so David is going to talk about this topic, and who is he? Well, he works in a small team at Firewire, and so yeah, as I said, it's 2 a.m. right now for David. So I'm so thankful that he's doing this at such a late hour of the day for him. So thank you again for being there. And so he's in charge of the platform to deploy to production at Firewire. And so, yeah, he does know a thing or two about DevOps, obviously, just probably more than a thing or two. But yeah, he's familiar with containers, AWS. He hasn't used Kubernetes yet, but is using Fargate and Terraform. So, if all of this is like Chinese to you, then maybe David can help you out, and you can always geek out with him about these topics. I'm sure he would be excited to talk about it. So he's super active in the local community in Spain, and he's been even mentoring a DevOps group in Valencia. So he's been very, very active as a speaker, as a community member, and also as a mentor at the Collab Lab. So thank you so much, David, for being here, and we're very excited to hear everything about DevOps 101.
Thank you for having me. I'm very excited to share as much as I can with you.
Absolutely.
Okay, so let's start. I'm going to share my screen. Okay, I'm sharing now, right?
You can see the screen. Absolutely.
Okay, so yeah, we are going to talk about DevOps, what it is, where it comes from, and we are going to do it by exploring its past, present, and future. So let's go. A little bit about myself. So some geeky things. I had my first computer when I was 13. The older ones in this call maybe recognize this computer. So also I have a background in telecommunications engineering. I switched careers and I have been working in this industry since 2002. I founded a couple of companies. I spent some years doing freelancing. I had to work across the stack, front-end, back-end systems management. In 2016, I joined Flywire as a site reliability engineer, and since 2018, I'm leading a small team doing what we call engineering productivity. We are in charge of the platform for all the shipping to production things at Flywire. Okay, so this is the agenda for this talk. First, I will introduce some concepts that will help to set some context. Then I will dive into what is DevOps. Then we will explore a little bit of the DevOps history and learn about some of its key principles and practices. And finally, I will explain how do we measure DevOps, and we will explore a little bit of the state of the art and the future of DevOps. The idea is to give you a high-level overview with some details and funny stuff. I hope it's not too boring. Okay, so let's go. Before we start, let me introduce you an important term, that it's operability. So a definition of operability, it's a term used in engineering in general to refer the qualities of a system that makes it work well with during its lifespan. And here, two important metrics that are often used for measuring quality and things. One is the MTTR, that it's mean time to recovery. This means how much time it takes for recovering from a failure, okay? And the other one is mean time between failures. It's how much time it's between two different failures. So this is two key metrics that you should keep in mind we will use them later. So, okay, so almost every production system, whether it's software or not, has an operations team that makes sure it's up and running and working properly. So this is an SpaceX control center where the operations teams controls the mission. So in any big enough company, you will have something similar with dashboards in the walls with transactions per second and things like that. But it resembles with less people, obviously, but it's something like this. So, okay, So going back some years, talking about operability in software, organizations in the tech industry started to face an interesting situation. So you can see here an image that represents developers and operations. So developers and operators had different and sometimes opposite motivations. So operation teams worked with the mantra of, if it works, please don't touch it, because they wanted the mean time between failures to be as big as possible. But developer teams wanted to make change and add functionalities answering to the customer's needs. So it was a never-ending source of friction. It was very slow and difficult to ship new features to the customers. So this friction has been sometimes referred as the wall of confusion. So the act of shipping code to production was something like this. Meaning, hey, ops teams, here you have the code. It's your problem now. So you can imagine how this ended. So this being the norm, I can understand the operation team motivation or to avoid changes at that time. So developers were not aware about all the operability consideration that makes code run well in production. It was simply not their problem. So what makes a software system operable? So if we want any software system to be operable, we should at least have a plan or a strategy for all these things: logging, metrics, alerting, backups, deployment, rollbacks, migration, security, and troubleshooting. And this is the bare minimum. There is a lot more to consider. Okay, so this leads me to this quote that I love: the most amazing abstractions, the cleanest code of beautiful algorithms are meaningless if your code doesn't run well in production. I love this one. Okay, so we have some context now, and we are able to start trying to answer this question. What is DevOps? So in its beginnings, DevOps was the response from the industry to try to reconcile developers and operations, to remove that friction with the goal of shipping quality code to production faster. So let's do a deep dive on this. You Google what is DevOps, we are going to see a lot of different answers, mostly from vendors, that they have some kind of offering and they have their own take on what DevOps means. So they are not good sources. Let's try with the Wikipedia. They say that DevOps is a set of practices that combine software development and IT operations, and it aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. It's good, but there is something wrong here. Also in this page, they say academic practitioners have not developed a unique definition for the term DevOps. Thinking that DevOps is with us since 2009, that's a lot of time to have a unique definition, but it's not possible. So let's try a more visual approach. So DevOps advocates for a deep cultural change across the whole organization that is based on values, principles, processes, practices, and tools. Okay, it's with the goal of being able to deliver value faster to the customer without sacrificing quality. Let's do a pause here for a moment. According to this, I see that 80% of what DevOps represents, values, principles, and processes, it's about people. Really, it's not tools or practices. It's about people and relationships and collaboration. There are a lot of success and failure stories of companies in the journey to implement DevOps. The only ones that succeed are the only ones that understand that you need to work on all these dimensions to be successful. So what is not DevOps? Buying some tools is not DevOps. Hiring a DevOps engineer is not DevOps. By the way, there is not such thing as a DevOps engineer. Implementing only one of the processes like CI/CD, but neglecting the rest of the dimensions, it's also not DevOps. So summarizing, doing any of these things in isolation is not going to work. As I say, it's a deep cultural change. There is not a magical recipe. Each organization will need to evaluate its needs based on their scale and maturity. So maybe we can try with a more accurate definition. DevOps is an evolving philosophy and a framework that encourages faster, better application development and faster release of software to customers. And the important part is the practice of DevOps encourages smaller, continuous communication, collaboration, integration, visibility, and transparency between all the participants in the software development life cycle. This includes dev, QA, support, on-call, SRE, security, IT, and now machine learning, business intelligence, etc. So, okay, let's go. I'm going too fast.
Yeah, do you want to slow it down, or how do you feel about it?
I don't know, because I normally don't rehearsal, so I don't know if it's going to be 30 minutes, 25. I don't know.
Oh, we can have plenty of questions for you.
There was one question of what was that computer on the first one of the first slides?
Sinclair's ZX Spectrum.
Oh, I should know that.
That's a famous computer in Europe, but it wasn't really very popular over here.
I thought about that. That maybe it was not that huge there.
That's funny you mentioned that one. Yeah.
What year?
Okay.
Yeah, this is actually the first computer I've ever used. So yeah.
Oh, nice.
Nice. Yeah, we're talking about like 25 years ago, probably.
yeah, certainly that. Okay, let's explore a little bit of history about DevOps. There are tons of examples of organizations that were successful by adopting the DevOps mindset. One of those organizations was Spotify. So in Spotify, at some point in 2013, they faced a difficult situation. They had more than 550 different development teams and a small operations team maintaining more than 100 services distributed across 6,000 servers and 4 different data centers. So the situation was not sustainable. So DevOps to the rescue. They started some important organizational changes. There were not 2 devs and ops big groups anymore. They created a small hybrid and autonomous teams with all the roles required to take full ownership of a small part of the system. So as you can see, each one of these little blue boxes was owned by a different team. And that meant that each team had the ability to develop and operate their part of the system with full autonomy. This was for them a game changer. And it's also one of the practices that has been more successful, having this hybrid and fully autonomous team. And you might be wondering how big were those teams? So the team size need to follow 2 pizza rule. So what's that? This rule has been attributed to Jeff Bezos, the Amazon CEO. and it states that no meeting should be larger than, no meeting should be so large that two pizzas can fit the whole group. This, depending on the size of the pizza, translates to teams between 6 and 10 people. It seems stupid and nonsense, but it's not really. There is actual science behind this rule. It's related. There is a lot of information. You can do a little research, but it's related with the number of social connections that a person can handle efficiently in a group. So it's a funny way to put some real world images in science reports. Other fun fact about DevOps was its public debut. So now it seems like DevOps makes a lot of sense, right? It feels natural to focus on people to solve problems. But back in 2009, it was too disruptive. In 2009, John Alspaugh and Paul Hammond gave a talk at the Velocity conference. The talk was called 10 deploys per day, Dev and Ops Cooperation at Flickr. So John and Paul were leading the devs and ops teams at Flickr, and they explained how they started to collaborate to achieve those 10 deploys per day mark. The fun thing is that it was too disruptive, as some people call them lunatics and other things. So it was not well received by part of the community at that time. Okay, so let's dig a bit on some of the key principles and practices of DevOps. First one is customer-centric action. This means that the main stakeholder should be the customer. So we need to have sort of feedback loops with real customers and end users. This we already saw in the Spotify case study. Cross-functional autonomous teams with end-to-end responsibility are key in the DevOps practice. Another more hard jargon way to say it is you build it, you run it. That means that all the developers have there are some people that do it, and there are others that don't do it. For example, developers on the team should be on call, for example. There are different ways to see it, but yeah, it's like it means that the team in charge of that part of the system has the responsibility for keeping that system up and running. Okay, so continuous improvement, it's very important to continuously minimize waste, optimize for speed, cost, and more important, ease of delivery, and to continuously improve the products and services offered. Other key part is automation. You should automate if possible in every stage of the software development life cycle. There are more principles and this is evolving, but these ones are the most important. So what about key practices? One of them is feedback loops, making them smaller. And this is one of the most iconic images for DevOps, where you can see this is all the phases of the software development lifecycle, and means that it's a feedback loop, basically, where the blue lines, it's more like the traditional dev part, and the yellow one is the ops part. So this translates in something that I'm sure that you already know or you have heard about. It's CI/CD. That means continuous delivery and continuous integration. CI/CD is the way DevOps implements these feedback loops into the delivery pipeline. So let's check what continuous integration is. This is a software practice where the members of the team integrate their work frequently, at least daily, by pushing the code to a shared repository. Each integration is verified by an automated process, including the testing. Oops, this is duplicated. Okay. Including testing to detect integration errors as quickly as possible. It was first described in 1991 and was adopted by the extreme programming methodology later on. And it's one of the fundamental practices of DevOps. It has a lot of benefits. By building a software with a process that it's known, reliable, tested version, and repeatable, you have a lot of benefits, reducing risk time, reducing manual processes. But for me, the more important one is this one. This helps to achieve security and confidence in the team. So you are not afraid to deploy on Fridays, for example. You are confident in the quality of your or all the process. This is actually an actionable advice. One of the, this slide is wrong. Okay, so 12-factor is one of the practices or one of the practices that allows you to implement easily continuous integration and continuous deployment. So 12-factor, it's emerged from Heroku's experience on the construction and operation of the platform. Heroku is one of the first platform as a service that was successful. So 12-factor is a series of recommendations called factors to build modern software applications that minimize the time and cost for new developers to join the project, maximizes portability between environments, are suitable for deployment on modern cloud platforms, can scale up without significant change to tooling or architecture, minimizes the divergence between development and production, enabling continuous deployment for maximum agility. So we are not going to, these are, if you are, the part of actionable advice, being familiar with 12-factor, it's going to be very useful for you when developing applications that are going to be easy to start applying any of the practices like feedback loops, continuous deployment, etc. They have a very well-crafted website in, I think, 15 languages, and it's worth to learn it and have a look. Okay, so how do we measure DevOps? So DevOps is culture, people, processes, collaboration. How can track and measure this success? There is an independent organization called DORA that has been in charge for some years now of a report about the state of DevOps practice across our industry. They collect data with a survey from more than 30,000 developers. And each year they craft a report with very useful information. So this report rank organization in 4 different levels according to their performance using 4 key metrics. The levels are elite, high performance, medium performance, and low performance performers. And the 4 key metrics that we use to measure DevOps are the deployment frequency. This means how many times you can ship code to production. So you can see that the elite performance can do that on demand. High performance, it takes a day for that. The medium performance, the 1 to 7 days to ship code to production, and the low performance from 7 to 30 days to ship code to production. There are a lot of companies still in that category. Lead time for changes. This is a metric that tells how much time does it takes for code after the push to the main branch to reach production. So you can see that elite performers are, you can, from the commit to the code being in production, less than an hour, and the rest for it's decreasing. You can see that lead time for changes for low performance, 1 to 3 to 6 months. That's interesting. Then we have mean time to restore. That is the one that we have seen at the beginning. It's about operability. So it's how much time does the organization need to recover from a failure, right? It's the elite performance, they recover in less than an hour. The last one is change fail percentage. Is from each deploy, how many of those deploys had some kind of failure. So with
I see a question from Stacy about lead time, and she's asking, like, what are some of the main things that would slow down lead time for changes? Can you give maybe some examples?
Yeah, if you have, for example, QA gates, like it depends on what's the path of the code for reaching production. How many staging environments do you have? There are still people that have manual QA gates for people doing tests with a sheet of paper, marking things manually, and doing, go there, click that, and okay, the drop down drops down, and you can select that. So there are still people that does that thing, and yeah, but it depends mostly on your delivery pipeline. How much stages do you have? For example, if there is infrastructure involved or not, it all depends on the pipeline. Also, we are going to see later about the state of the art, some practices people are doing for lowering this number by removing a lot of things that are standard, but there are some voices considering that are not longer necessary. Okay, so this is the way that we have to measure DevOps. And it's kind of new because the state of DevOps report has been around not so long. But yeah, we have now a way to measure our success or our success implementing these practices.
Hey, David, Stacy had another question, which was, is recovery time measured from when the failure starts, then new code is written and shipped, or is it when it fails, then you revert? Is that when the timer stops? Like, how do you mean time to restore?
Yeah, that depends on each company, really, because normally, depending on the company, the restore can mean only doing a mitigation, but not really fixing the source of the problem. That can mean that the problem has been mitigated, but the problem is still there. Maybe the day after the day after they have to start fixing or changing code or whatever, and it really depends on each company. There is some practice. It's called blameless postmortems, where in each for each incident there is a group that gathers together, checks what went wrong, and then in that report they capture all the dates about when things started to happen, and then they decide when when was really the service restored. So yeah, it depends on each company. Okay, so yeah, let's see some trends. These are graphs that you can see in the report. Here we can see some interesting data. This graph makes a comparison of the distribution of the organization between the performance categories. So you can see that the number of organizations that in the elite performer category is at most 3 times bigger in 2019 than in 2018. Also interesting that that category did not exist in 2017. So this we can read that as that a lot of organizations are starting to implement DevOps in the right way. Also, trending is this graph compares the elite performers with the low performers across the 4 key metrics, meaning, for example, that here the elite performers are able to deploy 200 times faster than the low performers. But as you can also see, elite performers are able to recover from failures more than 2,000 times faster than the low performers. So as in the previous one, we can read this as the industry is catching up about implementing DevOps in the right way, but there is still a huge gap between elite and the rest. And we are going to see a little bit why this happens. So how does it look like? For example, deployment frequency. So I can share this with you. This is a graph of the deployments per month at Flywire. So this October, we passed the mark of 4,000 deploys per month. As you can see, the blue ones are non-production deployments. Deployment means code that has been pushed to a branch and has been deployed to a real infrastructure. So blue ones are deployment to development, and the red ones are deployments to production. So I think we are doing things well, but we are now near the talk I was mentioning earlier about Flickr in 2009 or 10 deploys per day. We are now near that, but they were doing that in 2009. So we are catching up, but still the elite performers, they play in another league. So, okay, let's go to see some state of the art. We can see that principles, we can say that principles and values have not changed much during DevOps lifespan, but the rest of the levels in this graph are continuously evolving. As you have seen in the numbers, there are more organizations achieving the elite status when measuring the 4 key metrics. So we are going to dig a bit on the state of the art of some DevOps practices. But first, let me talk briefly about tools. This is what the actual tooling ecosystem looks like. No, that was a joke. But yeah, not really. It's more like this. This is the cloud native landscape. All these little boxes are the building blocks for modern applications. It's huge and it's growing like crazy. People complain about JavaScript frameworks, but this is another level. So I have, every time I put this on a talk, I have to do it again because it has grown again. So this is crazy. Yeah. Production testing. So testing production, what could go wrong? Wow, this is a joke. In the past, it has been kind of an stigma about testing in production, but it's actually a very advanced technique, and it's one of the differentiators for the elite performers right now. Production testing is trending. If you search it, you can find a lot of hits, some older and some quite recent. Test in production, yes, you can and you should. The what and why of testing in production, yes, I test in production, and so do you. Testing in production the safe way. When I started to be aware of this, I reached this tweet by Cindy, and it blew my mind. So works in staging is only one step better than works on my machine. You know, that is the typical excuse, that it works in my machine. This means that in most cases, the staging environment is not useful at all for this way of thinking. So in one of the posts, Cindy does an awesome work classifying different forms of production testing. And there is a very important distinction here. And it's that there is a differentiation between code being deployed and being released. So a code being deployed means that it's in production, but it's not receiving live traffic. That allows you to do some testing without impacting your customers, but in production, with the production infrastructure and all the networking settings, etc. Code being released means that it's in production and it's receiving production traffic. So there is very advanced techniques here, like shadowing. This means that you can, for example, deploy the code, but not make that code available to the customers. But you can replicate all the production traffic to the shadow, so you can check performance on peaks or whatever. So a lot of very interesting things here. For some organizations, this is a way to add an extra layer of confidence when shipping code to production. Other organizations use production testing they change their test strategy to reduce the number of tests in pre-production zone and delegate more responsibility in the production testing. And for others, it's really the only option they have, because their systems are so complex that there is no way to have an staging environment where they can test. Because, for example, Netflix is one example of this. One of the goals here is to increase the lead time decrease the lead time for changes. For example, by completely removing any staging environment. Yeah, this is the one I love the most. Other state-of-the-art practice is chaos engineering. So let me introduce you to the Chaos Monkey. So this monkey is a virtual pet created by Netflix, and he has or she has a very funny word. Chaos Monkey simply turn off servers randomly without warning. So this keeps it's like you release a playful monkey in a room full of servers like this one. You can imagine the outcome. So this keeps all the Netflix systems in a high resilient configuration, because the developers while they are developing, the Chaos Monkey is functioning. So they have to build their systems to be able to withstand these conditions. So this worked so well to Netflix and was so helpful to build more resilient systems that they built an entire army of monkeys. So we have here the Chaos Monkey, we have the Chaos Gorilla. Chaos Monkey was shutting down servers. Chaos Gorilla was shutting down entire AWS availability zones. Chaos Kong was shutting down entire AWS regions. And they do this for real. Each week they switch traffic between regions in a transparent way, simply to have to check the resiliency of the systems. And if you have worked with any kind of cloud provider with the scale of Netflix, that is a very, very big deal. They also have Janitor Monkey that takes care of costs, because it removes stale resources on cloud providers, and Latency Monkey. So what is chaos engineering? What's the definition for this? So the definition can be a discipline of experimenting in order to build confidence in the system capability to withstand turbulent connections in production. But I like more this definition. Chaos engineering is an effective tool to share knowledge and build empathy. And we go back to DevOps, it's about people, right? Okay, so I want to leave you with two quotes that I think are highly related with how the future is going to be shaped. One organizations that are in the elite performance category are continuously leveling up the playing field. They are continuously challenging all the foundation of the software engineering practices. So DevOps is a concept that is going to keep evolving to fit the needs of our changing industry. So this is a quote that I love, that it's not the strongest of the species that survive, nor the most intelligent, but the one most responsive to change, from Charles Darwin. And this is still valid here. The second one is any sufficiently advanced technology is indistinguishable from magic. From Arthur C. Clarke. This is actually happening. There is a trend to try to remove as much cognitive load as possible from the developers around the operations and infrastructure, so they can fully focus on delivering value. So at the end, where does your code runs will be only an implementation detail that will be indistinguishable from magic. And there is a lot of people working on this. I don't know, if, for example, if you know Dark Lang, that was a very exciting experiment with deployment times of milliseconds, and it's mind-blowing. So also all the work that is being done around Kubernetes, it's going in this direction, try to remove as much cognitive load as possible from the developers. So yeah, I think that's all. Thank you. We have some time for questions.
All right. Thank you so much, David. That was a nice and comprehensive presentation. That was really cool. So virtual claps. Thank you so much.
What was
go ahead, Andrew.
Well, yeah, I was gonna pull that question. So Heel's question out of the chat. So he asks, does DevOps differ if you deploy in the cloud versus your own servers?
No, not really. And also I can say that we are not the only industry where we can apply DevOps. As you can see, it's a set of values, principles, practices. So you can apply DevOps in almost every kind of industry. And that also means deploying on bare metal or your own data center and whatever. So as I said earlier, each company should evaluate its maturity, its scale, its needs, and choose the practices, values, and principles that they see fit.
Yeah, cool. I guess like some cloud providers there might be built-in tools or things that they provide, but all the kind of the approach and stuff is what stays consistent. Is that a way to say it?
Yeah.
Another question out of the chat is, Brett asks, what's the relationship between DevOps and OpsSec, so operation security?
It's in all this, security department has been left outside in all these trends, and they are becoming more aware that they need to be in the loop. They need to be in this. They need to be inside the feedback loop, and DevSecOps, what it's trying to achieve is to have security involved from the beginning. So they are present in all the cycle and not at the end. Being at the end is what is normal nowadays, but there are more and more companies that are including security in this. And also people from machine learning, business intelligence, all of them are trying to follow similar processes and practices.
Right. Stacey, you had a question?
Yeah. So if you are at any company in any position and you want to kind of find out more about like how DevOps plays out at that company, where would you suggest is a good place to kind of start looking? I know it's a very high level question. I kind of want to give like people an idea of like where they can go learn more about how it applies to them.
If they are applying it correctly, they should look for code, because other of the main practices of DevOps is infrastructure as code, for example. So they need to go to check where the pipelines are defined. Maybe it's Jenkins, maybe they use a software as a service provider. If there is not in code and has been done manually, they need to go to speak with the ones in charge of that. But I will say it's mostly code. And from code, you can go to the people that make that PRs or whatever, and you can start digging. But yeah, that's a very good question.
There's more going on in the chat. Let's see. Juliet, was that a question or just more of a statement?
No, it's just an observation.
Oh, okay, all right. Yeah, I thought about actually like the restarting the computers thing. one way to recover, if you have a system that leaks memory, one way to recover is just to have it. I've actually worked places where we just had it restart every couple of days. So it wouldn't.
At an old place of mine, we had a cleaning lady that would shut the computers down sometimes.
Oh no.
Oh wow.
Yeah, that's another form of chaos monkey. Yeah.
Amazing. Were there any other questions in the chat that I missed that maybe didn't scroll back far enough or something?
I don't think so.
I think there's a question from Sail. Oh, sorry, go ahead.
Oh, can you explain how a DevOps engineer is different from maybe an app developer? What is the role? How does the role differ?
That's a very tricky question because I don't believe that DevOps engineer should exist. I think DevOps engineer is a construct that is convenient for hiring managers and things like that. It's maybe putting system administrator and other label, but if you go to if you watch the offers about DevOps engineer roles, you are going to see that they are very heavily asking for tools, for the knowledge of tooling. So a DevOps engineer, it's normally the one that is going to be in charge of the Jenkins, or is going to be in charge of the pipelines and things like that. But it's not going to help in all the things that we have seen about collaboration and everything. It's going to be only a machine operator, things like that, or something like that. So yeah, I'm not sure if I answered your question.
Yeah, it does. It was just something that was unclear and confusing to me, but your answer kind of explains why it's unclear and confusing. So
It's not, yeah, it sounds like, because I was thinking the same thing too, Nakeem, as when I think of DevOps engineers, I think of the people who handle everything, taking it from when I merge it into the main branch and then it goes out into production. And there's this whole pipeline that sits in between it and all these processes around how that runs. And it sounds like what David is saying, it should be weaved into sort of everything, but generally it's not. And so I think, yeah, it's all based on how our companies are just running themselves, and us, I think as the tech community kind of trying to push for our teams to be more all encompassing when it comes to DevOps, rather than being oh, you know what, these two people on the team know everything about the pipeline. Cause then it's oh, if those two people are gone, then we're screwed if, things get out of control. So I too always thought of it as one thing, but now I'm kind of oh, we should all know about that, shouldn't we? Yikes.
I think I believe that teams should be composed by T-shaped individuals with some areas of expertise, but a huge base of knowledge of all the things necessary for operating your system. So I have seen, I have friends that are in those roles, the DevOps engineer, they are really simply handling pipelines, and they are the go-to guys when something broke, and they cannot live without causing some trouble. So I also believe in share in the sorry, I'm not finding the word in English.
Responsibility.
Shared ownership of the code. Yeah.
This has definitely inspired me to go learn about those pieces so that I can contribute and not be a sitting duck when it comes to things like catching fire.
You're going to be on call the week before Christmas.
I know.
So.
Stop. Don't tell everybody.
That's all right. I'm on call the week after that, and I know less than you do. So there was one other question. Sahil had a question about, if your application depends on a lot of third-party providers, does that make it harder to find the cause of a failure?
Yeah. I don't know if you are using AWS in your company, but we had a big failure in North Virginia some days ago, but it was like 6 or 7 hours of failure, and it was in a component that was cascading down to a lot of other components in AWS. So yeah, I think at Flyware we use 100 something platform as a service, software as a service applications, and a lot of them are for the infrastructure. But yeah, it's and we are moving money, so it's not, and we have to comply with very strict regulations when you move money. For example, we comply with a regulation that is called SOC 2, and that means that an SRE that is cannot touch code, application code without reviews from 2 developers, and developers cannot touch code that is touching infrastructure. So yeah, I lost my train of thought.
That's all right. It's late there for you. So how does that relate to, is observability one of the things you do to better understand the interplay between systems?
Yeah, that's trendy right now also. A simple answer is that you cannot have feedback loops if you don't have the observability in place. It's impossible for trying to lower all the metrics if you don't know how your system is behaving, and you cannot ask questions to check why your system is behaving the way it's behaving. And there are a lot of dimensions of that. With monitoring, for example, you only monitor the things that you know that can go wrong. But with instrumentation and observability, what you do is make the system, build the system in a way that it allows you to ask questions about things that you don't know. So if for fixing a bug, you need to put some tracing or change code, that means that you have to work better. You have to work more in your observability. But yeah, it's basic for continuous integration and continuous delivery to have monitoring, tracing, logging, etc. It has to be in place.
Cool.
All right, maybe we can take one last question if there's one. Last call.
I'm not yet sleepy, so.
Were you drinking a coffee there?
Tomorrow.
Yeah, it's Coke, but it's empty.
Okay.
No.
All right. Okay. So much. Thank you so much, David, for that presentation. There's a lot of props in the chat as well, where people are thankful for bringing light to a topic that they didn't know much about. So again, thank you so much for explaining what DevOps is to us. Especially, I love the fact that you approach it from like the idea of like where it came from and where it's going. That's such a great approach to it. So yeah, thank you everybody for being here and for participating and for asking so many questions. And yeah, I guess I'll just kind of tease the next meetup in 2 weeks. So on Wednesday at 5 p.m. Pacific time. It's not on meetup.com yet, but we have Tim Fitzrandolph, which is an indie game creator who works at Disney. And so we are going to dive into game development, and he's going to talk about how you create a game from prototype to finished product, to the finished product as a small team. So this might be a little bit different from what we've heard before here, but I think it's still going to be a very amazing topic to hear about.
Yeah, Tim is a master game builder. You may have heard of the game Jelly Car way back in the day, like 10 years ago or something. It was an iPhone game that had this car that would had this amazing physics where you could make the wheels bigger in order to get it over obstacles and different things. And then he was responsible for Where's My Water, which is a kind of a hit Disney game that was the first game that led to a movie, and instead of being the other way around, usually at Disney it was movies led to games. And then he started his own studio, and it should be pretty phenomenal. He's an amazing engineer.
Right. Yeah, absolutely. I think so too. All right. Thank you, Andrew. And again, thank you, David. And I hope you get some sleep. Unless, if you say you're not tired, maybe you just not even go to bed.
Yeah.
I have a meeting with my team at 9 a.m. to have lunch.
Oh my God.
Lunch now, sorry. To have breakfast.
Breakfast.
Oh. Well, again, thank you for all the work and for being here for us at a very inconvenient time for you. So yeah, thank you so much, everybody, and yeah, we'll see you in 2 weeks.
Bye, everyone.
Thanks. See you later.
Thank you. Bye.